Okay, here we are at part 3 of the Elektro build, and this one's going to be a question of balance, but we're going to talk about other things too, like I went ahead and did the friction adjust on the arms so that if you wanted them in any position you could put them in that position without breaking anything. Okay, what else? We talked about the adjustable arms. Let's undo these wires so we can lift the body off. Obviously this is where I'm going to put a screw in the end to screw the body to the lower section, and a screw there to that. Of course the batteries reside in there, 2 AAAs. And what else? Oh, I was going to mention, those of you that may be new to 3D printing or haven't used the silk PLAs. This is a gold silk, but any of the silks, they don't have as strong of layer adhesion. The plastic itself is as strong as any PLA, but the adhesion between the layers, like this is a layer and this is a layer, that bond isn't as strong. And because 3D printers lay layers in rows like this, if you try to twist them on that layer, they can separate. It's going to work fine for this project. I'm just letting you know in case you weren't familiar. But on the same token, there's a new slicer setting that hopefully will come out for all the printers, because it doesn't really have anything to do with the printer. It has to do with the slicing program, where they're going to do what's called brick. We've got 2 layers, and then let's say your thing is a couple layers thick, always is, unless you're in vase mode, and normally they'd be stacked up like that. Well, now they can offset it like this. So if this layer breaks, this one's still intact and makes it twice as strong. They call that brick because it's like if you were doing brick and mortar. And I think the only reason it hasn't come along before now is there's either a patent or some sort of registration. There's a legal reason, but I think some of the companies are going to push it anyway and just see what happens. We got off on tangent. Let's get back to the project. So if you've watched in the link down below, or any of the other links that you find on YouTube of the actual Elektro robot back in 1939 at the World's Fair performing, you know, besides the mummy walk where only this leg actually bends and moves and this leg over here stays stationary, the other thing you'll notice is that the feet are actually running in tracks below the floor. And there was 2 reasons for that. One reason was keep the thing going straight, especially with a mummy walk going on, and the other reason would be to keep it from tipping over. So because we're making a toy based off the original, tipping over was going to be a problem, and I knew it was going to be a problem all along. And we only had a couple options. One would be to shift where the legs were in the body. That wasn't really an option. Make the feet longer. I didn't really want to do that. So what I've ended up doing, once I had the body and the batteries and everything on there, and seeing that it would stay up on its own, but it only took a small breeze to tip the thing over, I decided I was going to add weight inside the legs. So you can see down in here, let me turn this light on, if I can get it to turn on. There we go. So I hollowed out a place in there where if you go to any automotive store or Amazon online, you can buy what they sell as wheel weights. These are the weights that they normally stick on the metal rims of your cars to balance them. Now, these are the 1 ounce size. It's generally the largest of the sizes, and they have an adhesive which is very strong. I mean, it'll hold the weight onto a wheel in any weather condition, right? So my idea was I would slide the weight into that slot like that, non-sticky side down. I would have removed this protective coating, get it slid in there, and then simply flip it over that way so the adhesive is now against that side. Then I'd prepare a second one, and I'd put it in there metal on metal, having already removed that, flip it around and stick it down. Then you can cram a screwdriver or something in there to really compress those sides and get them stuck on there good. And if you're worried about them coming loose for any reason, you could come up in here with some glue and just glue those edges, as long as you don't get it, you know, in the way of where we're going to be putting our wheels and everything else. Each one of these weights is 1 ounce, so that gives me 2 ounces of weight per foot, and that's what I that's what I put in here. And of course you can't see it once the ratchets are in there, but they're in there. You can feel it. Adds a lot of weight. Now that helped a lot, but the thing was still a little bit too tippy for me. I mean, you got to look at it and think, well, okay, most of the body is back here behind the feet, and I've got the batteries in the body behind the feet. So I did experiment with, and you can see a little bit of the black residue in there, experiment with putting 3 of those weights in here, so 3 ounces in the body up there. And that actually worked, but the more I thought about it, the more I did not like having all that extra weight in the body, because if the thing did fall over, it just makes it all that much heavier. It's just going to do that much more damage, right? So I pried them out as best I could, and obviously some of that glue just did not want to let go. But I got it out of there, and I went, okay, how am I going to fix this? Well, this leg was the legs that you've seen all along, and this part is level to the base. In other words, these two are perpendicular with each other. I decided that I could live with maybe a 2-degree slope. If I could change this piece right here where the rods run, angle it 2 degrees. And that's what you just saw here. These are angled 2 degrees, and that made it super stable. Oh, and the other change is where the wheels are in the back. I could move that wheel hole back another 2 millimeters. That doesn't sound like much, but every little bit helps. But that got the wheel back as far as I could. Before, it was like the front. See, there was quite a little bit of gap there. Move that back too. So added the weight, moved the wheels back too, took this top plate and tilted it 2 degrees, and that gave me something that worked. Unfortunately, making all those changes to the file did make the file, the STL file in the end, come up with, when you put it in most slicers, it's going to come up with an error that says, where does it say? It's going to say X number, let's say 3,693 non-manifold edges. I was unable to correct that to get it back where it wouldn't say that in any of the STL repair file devices I could find online or on my computer. And granted, my computer is over 15 years old, so it's not super horsepowered, you know what I mean? Somebody might be able to take this file and correct it. But it doesn't really need to be corrected. I've tested this this file in Prusa Slicer and Bamboo Lab Slicer. Of course, you got to keep in mind, Prusa Slicer is just a version of Slick 3R, which was the original open source slicer that Prusa worked from. Bamboo Labs is just a version of Prusa Slicer, and there's a couple more slicers out there that people use that are variations of the original Slick 3R. But I also tried it in, Christ, what's the name of the other popular one here? Let me take a look at my computer. Oh, I also tried it in Cura, no problem there. So the file slices fine. If you get an error message saying non-manifold or something, just slice the file anyway. It will work. It'll print just fine and look just fine. Don't worry about it. So that got everything stable. That got everything balanced. It added a lot of nice weight to the feet. I say the new arms go in real easy. There's just some screws that 632 screws that I'm running in here, and they go all the way in, and they screw into on the inside of the robot. These little plates, they just screw into that, and that gives you the levers. And of course, like I said earlier, when you go to put this thing together, hold it this way so that the levers will be all the way against the front of the body. Then if you take, these wires are going to fight me, I think. But then if you take this part and aiming at the correct direction, stuff it in there, like so. Now they'll fall down against those pegs in the feet. And you can then connect your motor wires and the battery wires, one of which has to run through the switch if you want to be able to turn it off and on, like so. Didn't mean to lift that up. And then we're going. So What else? Well, in the next video, we'll probably talk about some of the heads. So far, I've had 2 different heads submitted. One head is AI generated from pictures, and the other head I think was done in Tinkercad. And in both cases, I've reworked the heads to give them a larger neck disc so it'll fit on this body that I have designed. Of course, scaled them down to fit this body, and hollowed them out and put in holes in the eyes so that 3mm LEDs can go in there. So we're going to talk all about that in the next video. And there's something else I was going to talk about. Well, I can't remember what it is right now, but if any more of you were going to do heads, do it. We're just going to, in the end, we'll just put links to all the heads, and anyone that wants to build one of these can select their favorite head or modify the head or do whatever they need to do that makes them happy.